An RGB laser is that beam source that emits red, green and blue lights in form of laser beams, either as a separate beam for each color or a combination of all the three colors in one beam. Through the process of additive color mixing, which is achieved through combination of these lights, a number of many other lights can be obtained. RGB lasers are being exploited as an alternative to arc lamp sources beamers. Although arc lamps have been used for a long period as a source of beams, particularly because they are much cheaper, they suffer from setbacks such as limited lifetime, high wall plug efficiency is impossible, poor image quality as a result of poor spatial coherence, and the fact that available color space is not wide enough. For these reasons, the former is becoming more popular. RGB sources are much more popular. Beams from these sources are known to be coherent in both wavelengths, both in time and space, allowing for inferences. If the change in phase properties is able to take place at the same time, over a long distance, and at the same period of time, then such waves will produce a very clear image. It is possible to cancel such waves with a similar with opposite phase. These lasers are known to produce beams of the three primary colors with very narrow optical bandwidth, making them close to the monochromatic light beams. They are thus capable of producing very clear images on mixing. The reason why they are getting more application, like in cathode tube displays, color printers and lamp-based beamers. RGB sources, however, suffer from a major setback, given that the power level that is emitted is usually of low level. Most cinema projectors, for instance, require up to 10 W per color or even more. This level of power sufficiency, maturity or even cost effectiveness is still beyond the existing RGB scanners. When it comes to beam quality, these machines have to operate with high quality beams for them to perform effectively. In situations where optical modulators is not practical as a result of low power miniature devices or for any other reason, the RGB sources are fitted with power modulators for better signals. Using laser diodes in particular helps achieve modulation bandwidth of tens to hundreds of megahertz or even higher resolutions. There are many methods of constructing RGB lasers. 3 lasers with each emitting a particular light of a wanted color is, for instance, an approach that has been used for long. These visible light beams are, however, limited in performance as compared to those that are infrared based. The other method is the use of an infrared solid-state laser, where a single near-infrared laser generates a single color that then undergoes through different stages of nonlinear frequency conversion to produce the 3 colored beams. There are many other schemes of producing the desired wave lengths, such as through combination of parametric oscillators, some frequency mixers, and even frequency doublers, in addition to other methods. Technological advancement is, however, set to completely address the challenges with an RGB laser. Just like other forms of lasers, they are set to be used in all other areas where there are need for lasers, like in hospital machines, cutting technology, and in entertainment industry, among others.